So if Malthus and Ehrlich don't really understand what's going on with overpopulation, or if overpopulation is a myth, what's really happening? Well, to look at this, it might be useful to examine individuals like Julian Simon. Julian Simon's another economist, and in the 1980s he would end up having a major impact in the study of overpopulation through the discussion of resource use. Simon makes a very bold statement. He states, "World population will never outstrip Earth's limited resources, because Earth's resources are unlimited." Yeah, I just said unlimited. I know, that flies in the face of everything you've ever been taught about natural resources. How could that possibly be? Well, it would be helpful if we looked a little bit more closely at what the definition of a natural resource is. A natural resource is a naturally occurring material with utility in a culture. The key feature here is utility. Utility means it's found in abundant supply and that it's useful in that culture. So it has to have a technological application, but it also has to be found in abundant supply. If the supply becomes short, or is already short, the utility of that resource actually decreases because the material becomes too expensive to use. Shortages of a resource stimulate innovation and change our perception of that resource. In fact, resources are only resources because we perceive they are, right? So if they are in short supply, what happens here is they become very expensive. And as they become expensive, it becomes much more justifiable to companies to devote money into research and design to develop workarounds that achieve the exact same result with that resource without utilizing it. So valuation then plummets as we develop those workarounds and as those new technologies come online. Let me give you a nice example. In the 1970s, copper becomes very expensive as the world supply plummets. Why does the world supply plummet? Well, think about what's happening in the 70s. We're finding that worldwide electrical use is becoming very common, so it's being used in wiring. We're finding the world is being plumbed, so it's being used in plumbing as more and more people get running water and sewer lines. We find that it is being used to run telephone lines. So of course, it's in very high demand. There are finite amounts of copper in the world, and so it becomes quite expensive. But I want you to stop for a minute and consider what materials are now used for those purposes. Yeah, copper is still used for electrical purposes, but it's far more common today to plumb your house with PVC tubing. And you'd really miss your wireless and your silicon transmission options if you had to go back to copper. Really? Consider dial-up. Consider taking this class on dial-up. Would you be able to watch this video? How long would it take you to download it? It would be awful, right? What happens here is that research and design was devoted into developing new materials and new workarounds as copper became expensive. Copper became a less important resource to us as it became expensive, right? What happens here is that we have an example of exactly what Julian Simon is talking about. Earth's resources, that is natural resources, are in effect unlimited because they're only resources so long as we perceive them to be a resource. As soon as they become expensive, they're no longer good resources to us and we abandon them. We develop new resources. What this then means by extension to us is that overpopulation and the use of resources is never going to lead to starvation or to war over resources or human extinction. Let me give you an example looking at the food supply. The UN tells us that roughly 1/3 of the food produced every year around the world is actually wasted. It's lost, it sits in port, it rots. Our problem is one of distribution. It's not one of production. Today, famines are due to problems with the transportation of food and resources to food insecure locations, due to war or politics. It's not due to a lack of production. Now still, no one's going to deny that increasing population is going to lead to lifestyle changes and to changes in our environment. But it is up to us to decide what changes we feel are acceptable or are unacceptable. And we need to ask ourselves, what sorts of population changes are we going to expect in the near future? To really look at those population changes, it's best to examine something called the demographic transition model. This model is excellent at tracing and predicting population change over time, and it applies to every culture under the sun. It tells us, by even the most conservative estimates, the population is going to top out at 10 billion people by 2050. We're currently at about 7.4 billion people as of 2018. Within 50 years, our population is going to shrink back to 7 billion people. And how do we know this? Well, to understand it, we have to examine the different stages of the model, and we have to look at what is happening to populations in terms of birth rates, but also in terms of economies and development. So let's look at these individual stages. So in stage 1, you'll note the population has a very low growth rate. Actually, the doubling rate is something like 1,000 to 5,000 years. And this is because you've got very high birth rates and very high death rates. So what's happening here within this society is that there's probably no disease prevention for these people. You're looking at occasional famines or wars occurring. So that creates a relative balance between birth and death rates. When a population is in stage 2 of the model, you're looking at an exponential increase in population. Because you've got high birth rates, but your death rates have declined pretty extensively. Those high birth rates are due to improvements in the food supply. Maybe there's been an agricultural revolution among these people that has led to high amounts of food to feed everyone. And probably what we're looking at are improvements in public health leading to that low death rate. So we've got maybe an increased survival rate for children. Perhaps people's life expectancy is much longer. In stage 3, you're looking at declining births and very low deaths. And that's going to lead to a slowing population growth rate. Now, the growth rate is still occurring, but it is slowing over time. Now, what's happening in stage 3 is that you're probably going to see this population transitioning into industrialization. Usually you're looking at rural to urban migration with this population. And as people migrate into an urban locale, we see that family sizes shrink, which accounts for that lowering birth rate. By the time you get to stage 4 of the demographic transition model, you see very low birth rates, but also very low death rates. So your lifestyle is excellent, your quality of life is excellent here, but most people live in an urban locale. So family sizes are going to be fairly small. And what this means is that population is relatively stable. You're going to see that you're not going to see much growth at all, but you're also not going to see real shrinkages. Now, some people would argue that there's actually a 5th stage to the demographic transition model. You'll just have to make this one up in your head. And in the 5th stage, you'll find that the death rate actually slightly exceeds the birth rate. So we have low births, but an increasing rate of death. And that rate of death may have increased slightly due to lifestyle diseases. People who live in societies in the 5th stage of the demographic transition model live very sedentary lives. They probably live in cubicle farms, so there's high rates of heart disease and obesity, very high rates of things like diabetes, and really what we're describing are societies that are post-industrial in nature, very much like the sort of societies we find in places like Europe in places like North America. When we examine South and East Asia, what we see are societies that are in a mix of these stages. India and China are well within stage 3, while we look at countries like North Korea, and we'd have to say, boy, we're really looking at countries who might be in stage 1 or maybe stage 2, depending on the policies of the government at the time. Countries like Japan, with incredibly high rates of industrialization and very low birth rates, are well within stage 4 or maybe even stage 5 of the model. Hopefully we've given you some ideas to think about regarding population and densities and resources and these ideas of overpopulation. What we can say is that human densities vary over the Earth's surface based on how arable the land is, but also based on how developed the country is. Humans are not in danger of running out of natural resources, although the resources they utilize will undoubtedly change with new technologies and pressures. Populations will reach an apex of 10 billion people within the next 50 years, and then begin decreasing almost immediately due to changes in development.